Hello, everyone, and welcome to ROKStudios. I'm Stan Miller. I'm PR and Analyst Relations Manager for Rockwell Automation in the EMEA region, and I'm joined today by Michael Lampe. He is Innovation Manager at Meurer. Michael, welcome to the studio.
Yeah, thank you for having me. You're right, I'm Innovation Manager at Meurer Verpackungssysteme GmbH. That's a division of ITW, and we are specialized in secondary packaging. So secondary packaging, that are the things you see at the retailer or maybe at home. We'll pack them around the products. And when we talk about innovation manager, it's always a big word. I mean, I'm in charge for the customer back innovation at Meurer. That means we want to come in discussion with the customer, find out what does our customer need, and then we try to find a value or solution to help him and create a value and grow together. So that is our goal when we talk about customer back innovation. In other words, I would say we translate the market requirements into real equipment.
Got it. Michael, that's perfect context for our discussion. Today, we're here to talk a little bit about modernizing secondary packaging for sustainability and agility. I can't wait to get to this topic, so I'll just jump right in. My first question for you. What fundamental industry shifts or customer signals indicate that now is the right time to rethink secondary packaging machinery rather than continue incrementally improving existing systems?
I would say in the past, reliability and performance was the top priority for equipment in our segment. At the moment there is a shift. There is also reliability and performance is important, but also some things like energy efficient, sustainability are coming more important, more and more, and we have to get it in one machine. So we can't say now it's sustainability, but it's not that fast as you are used to work with. We have to combine it in one machine. So that's the goal when we talk about sustainability and all the things, all the shifts in the industry. Not only all the keywords and buzzwords, we have really built solutions that fits in the current plants. That means small footprint and also the same speed, but less energy consumption and everything you combine with sustainability, or you want with sustainability.
Michael, that's great. Let me ask you, as you know, paper-based packaging introduces very different behaviors on the line. From an innovation standpoint, what are the biggest technical hurdles a packaging specialist must overcome to make paper viable, particularly at high speed?
Yeah, you're right. Paper behaves different than film. And in the past, we built and we still build machines for film packaging or case packaging. And now we expand our portfolio to build solutions for every alternative, for every product we build in film or in carton. We want to have an alternative for the customer based on paper or something paper-based material. And the challenge there is paper is not film, so it behaves different. That means when we talk about fast, high-speed solutions like we build, we have to build a machine that can detect these different behaviors. Film I would say, was easier to handle. Now, when we talk about paper, and paperization is at the moment a big topic in our industry, we have to learn we need more sensor data, we need other movements, precise movements in our machines to solve that in our high-speed applications. Also, the whole environment around our equipment changes. There is a problem with less qualified operators, but also we say the machines getting more complex because we have more sensors, we have more technique in these machines to handle all these new materials. And the products itself, I mean, you see, for brands it's important to have own products and own designs. Our machines have to handle that. That means we have new materials, different products, and also more technique to handle that in our equipment. But also the operator have to handle this or have to work with machines with more technique into it. But there are not that much operators and also qualified operators. All this in one package, that is a challenge we now have to solve or handle it.
Michael, so just kind of unpacking everything you said, machines need to be more and more sophisticated to meet more and more demands, yet be workforce friendly, and in order to be as easy to use for operators. I hope I think I understood correctly. Let's talk a little bit about future-proofing. You've emphasized that future-proofing requires smarter, data-driven automation. How do advanced controls and real-time insights change the way manufacturers can approach flexibility and predictive maintenance?
Yeah, the predictive maintenance, everyone is talking about getting data. I think that getting data is important, but it's not the goal, getting the data. The question is, what do we do with the data? What are the real business cases behind that? You will see a lot of buzzwords out there that say, okay, we have now this data, we have that data, but we try really to focus on the problems of the customer and look, what are his problems when we're talking about our machines? And which data do we need? Which data do we have? Or which data do we need with other sensors, or we need it earlier? And then we say, okay, data is there, we need data, or we need it not, but we need data to solve his problems or to help him in this new environment, advanced automation you called it. That means you are in a high automatic, robotic environment. You have to be stable with your equipment. It has to be run stable. You don't want to be the bottleneck in the whole line. That means if there's a robot giving you or filling your magazine, you need to communicate with this robot. You now in a whole line, you have to communicate with all the other systems. That's very important. We aren't at the moment. We can say, okay, there are data we share with some systems about the production things and so on. But now we are in a whole network based on sensors. Have to share them with the others to know who is working there, which system needs what, who has a problem. And then in the future, we also want to say, okay, we know, for example, in one of our machines, there is a knife not that sharp or glue on the knife. In the past, we would say, okay, how do we measure that? Now we say we have to know that because we want to do this maintenance at Sunday and not in the week. Downtime we don't want downtime cost of our machines. So these are the real cases we try to solve now and we try to implement in our machines. That's important, not the business case itself. We really say the business case has to be based on a problem of a customer, and then we say predictive maintenance is a tool. It's not predictive maintenance for predictive maintenance.
Absolutely. Yeah. No, that makes perfect sense. We were talking a little bit about sustainability earlier. Let's take a kind of a similar follow-up question in that area, energy efficiency. Energy efficiency and material reduction are major pressure points for producers, as you know. How does sustainability influence machine design?
As I mentioned, paper is not film, for example, and you have to look at the whole equipment. So total cost of ownership's getting more important. At the whole machine, we say, okay, you have the materials, but if you have a stable performance and stable running machine, you don't produce waste. So it's also a thing of sustainability, don't producing waste. Then you look at the conveyor belt through our machine. Smoother motions means less energy consumption. So if you don't have stocking lines or something like this, smoother the control machines or you control the conveyor line, the better for the energy consumption. And all these things are now included in the development. So it's not an add-on or a feature. You buy, now I need the add-on sustainability. No, it's included in the whole development and part of the whole product life cycle, I would call it. So you not add sustainability at the feature on the machine. You say during the whole development, it's in every machine, and we look at every part of the product cycle.
Got it. Sustainability, kind of foundational to machine design. Understood. Last question for you, Michael. What emerging trends, whether that's materials, digitalization, or customer expectations, do you think will shape the next few years of packaging innovation?
I think to conclude it, we would say now at the moment we talk a lot about paperization and material changes, but that's at the moment. So when you look at the machines in the market, you see, okay, everyone is dealing with that and tries to implement this solution. The next step for me is the predictive maintenance, to prepare the machines and the equipment to run in an, I mean, now I have to use a buzzword, dark factory, but first I have to know everything about my machines and change it from now I have to act because there is a failure to we know the data and we can use the data to guarantee the performance in a high automated factory or line and so on. So I think this will be the trends for us. First paperization, then predictive maintenance, and the goal must be our equipment in the dark factory fully automated and guarantee always with the high performance the customer is used from our machines, and also, for our case, the low footprint. So German engineering and low footprint is also one of our goals, and I think we will finish that in the future. Yeah.
Excellent. Michael, you've shared some great insights with us. Thank you so much for joining us in the studio today.
Thank you.
Thank you for watching. If you'd like to learn more about industrial automation and digital transformation, visit rockwellautomation.com.